Hello and welcome to Mr. Tompkins EdTech and a brand new series of videos aimed at helping you prepare for your GCSE mathematics exams. In this series I'll be giving a complete walkthrough of the GCSE mathematics practice papers to help you prepare for your exams this summer. Now there are not so many of these and you don't want to squander them, so make sure you try the paper yourself first before you look at these solutions. This particular paper is AQA June 2024, paper 3, higher tier. Check the front cover of your paper to make sure it's the same one. If it's not, have a look through the playlist linked above, which includes all the GCSE Maths video walkthroughs I recorded so far. I'm busy recording all of the GCSE practice papers, so if the one you're looking for isn't there already, why not subscribe by clicking the big red button below and check back in a few days. Don't forget to click on the bell so that you'll get a notification when I upload the next paper. I'll put timestamps in the description below, so you can choose to watch the whole thing through, or you can click on the timestamp and jump to the particular question you need help with. If you have a question, check the comments below as someone else might have already asked the same thing. If it's a new question, leave it in the comments and I will try and answer all of them as soon as I can. Don't forget to mention which question on the paper you're referring to and try and be as specific as possible. Finally, if this video helps you with your revision, please give it a thumbs up. It will really help me out, and why not share the link with your friends because they might need a helping hand too. Okay, let's get into it. Question 1. Here are the first 3 patterns in a sequence made up of small squares. So I've got pattern 1, 2 and 3. On the grid, draw pattern 4. Okay, so you can see with this, the corners are staying the same from pattern to pattern. So carries on having these 4 squares in the corner. What changes each time is the square in the middle. I've got a 1 by 1 square, then a 2 by 2 and then a 3 by 3. So my next pattern is going to have those 4 little yellow squares around a 4 by 4 square, I should imagine. So to draw that then, I'm going to have square here, and then my 4 by 4 square in the middle. And it's going to have its 2 little yellow feet down here then, isn't it? Yeah, so each iteration of the sequence, you're going to get that square in the middle growing by 1 in each direction, but you're going to continue to have the little 4 little ears. Okay, so that's it. Part B says the expression for the number of small squares in pattern n is n squared plus 4. So we saw that it was a square plus the 4 little corners. Work out the least value of n for which the number of small squares is greater than 500. So what we want then is n squared plus 4 being greater than 500 then, don't we? That's what we want. Taking 4 away from both sides, I'm going to get n squared is greater than 496. So what is the square root of 496? On my calculator, it doesn't come out to be a particularly nice number. It's 22.27. So square rooting n is going to have to be bigger than 22.27. Now normally when you square root you have to take care that you don't lose a solution, do you? Because there's a plus and minus solution for these. But in this case n has to be positive, so I could ignore the negative solution of this particular quadratic and just crack on. So n needs to be bigger than 22.27. Well, the next whole number, because n needs to be a whole number, remember it's the pattern number, so the next value of n it could be is 23. So when n is 23, it's going to be 23 squared, which is plus 4, which is going to be slightly larger than 500. Question 2. Use Pythagoras Theorem to work out the value of x. Give your answer as a decimal. So I've got the longest side of a right angled triangle here, so I can use the classic Pythagoras Theorem formula, c squared equals a squared plus b squared, where a and b are your 2 shorter sides. So in this case, it's going to be 24 squared plus 31 squared. Okay. Now, I'm just going to type it all in at once. I don't have to faff around with the calculator. So I'm going to say c is equal to, and then I'm going to type into my calculator the root of, and then 24 squared plus 31 squared. Okay, and then that should give me the answer in one go then, shouldn't it? So that comes out to be 39.2 to one decimal place. So 39.2. Before you move on, it's always a good idea to think, is your answer sensible? 39.2 looks about right in that triangle, isn't it? It's slightly longer than the 31 and the 24, and remember it is the longest side, so yeah, it does look okay. Question 3, Rick claims that most of the flats in his 8th-floor building are energy efficient. He samples 45 flats from floor 1 to 5. Give a reason why this sample may not be useful in testing Rick's claim. Well, it's an 8th-floor building, and he's only tested, he's only sampled from floors 1 to 5. So he has not sampled any flats from floors 6 to 8 then, isn't he? He's missed out those top 3 floors. So his sample may not be representative. Okay, so I think really he should have picked like flats from each floor, really. I could imagine the top floor is where most of the heat goes out of the building. I might be wrong about that, but you know, it's certainly a possibility. Question 4, 3 lots of x minus 1 is identical to 3x minus 3 is an identity. Okay, so tick one box. It is true for all values of x, it is true for some values of x, it is true for no values of x. Well, identities are identities because they are true for all values of x. Question 5, the front elevation of a cuboid is shown on the centimetre grid. The volume of the cuboid is 42 cubic centimetres. Draw the side elevation. Okay, so we got the front elevation and we want the side elevation, which is that face. Okay, now we know the total volume is 42, and we know we get the 42 by multiplying the length times the width times the height. So I guess the height is 2, isn't it? And the length is 3, which I'm getting from here. Look, so this is the front face. So that's 2 by 3. So what we need to do then is work out like that one, so we can draw this side elevation. I already know that like it needs to be 2 centimeters tall because it's the same as the other height, isn't it? But I need to know like that, like the width of this. Okay, so the length I know is 3, the width is what I want to try and find, and the height is 2, and I know that multiplies together to give me 42 because it tells me here. Okay, so then rearranging that, find W. So I've got 6W is 42, so W must be 7. So that must be 7. So the side elevation has to be a rectangle with dimensions 2 and 7. So let's quickly draw that. Okay, so that's going to be my green face then, isn't it? It's going to be a 2 by 7 rectangle. Question 6a. On Monday, Lars swims 50 metres in 40 seconds at a constant speed. On Tuesday, Lars swims 1.5 kilometres. Assuming he swims at the same constant speed as on Monday, how many minutes does he swim on Tuesday? Okay, so this is a 2-step question, isn't it? It's distance, speed times twice over. So in the first day, so this is on Monday, what's going on? Distance, speed, time. What have we been given here? Swims 50 metres. So that's a distance, isn't it? 50 metres. And he swims it in 40 seconds. So time is 40 seconds then. Okay, so what we need to do is work out speed for Monday, and then we can assume he then swims the same speed on Tuesday. So covering up the thing I want to find, speed, that tells me it's distance divided by time. So speed equals distance over time, which in this case is going to be 50 divided by 40, or 5/4, which is going to be 1.25 then, isn't it? And what's that in? That's going to be in meters per second, because the distance was in meters and the time was in seconds. Okay, so that's my speed of Lars swimming on Monday. So assuming then on Tuesday he swims at the same speed, I'm going to do another DST calculation. So what have I got this time? I know the speed this time because we're assuming he swims at the same speed as last time, which was that 1.25. Okay, what else do we know? Oh, he swims this time a distance of 1.5 kilometers. So my new distance here is 1.5. Now that's in kilometers. Now you have to take care because my speed is in meters per second. So I've got a mismatch of units here. If I'm going to use meters per second, then my distance needs to be in meters. Now there are 1,000 meters in 1 kilometer. So 1.5 kilometers is going to have to be 1,500 meters then, isn't it? Okay, so then I can work out my time from there. So covering up the thing I want to find time. Time is distance over speed. So time equals distance over speed. And now it's going to be 1,500 divided by 1.25, isn't it? So calculator, what is 1,500 divided by 1.25? Now that comes out to be 1,200. Now again, take care of units. I was working in a distance of meters and a speed in meters per second, so that is going to be in seconds. But the question does say how many minutes is that then? So seconds into minutes, there are 60 seconds in a minute, so we're going to have to divide that by 60 then to find minutes. So 1,200 divided by 60, that is 20 minutes then. Okay, so then the answer is going to be 20. Now, in fact, on Tuesday, Lars swims at a slower constant speed. Well, who would have thought if he'd swam 1.5 kilometers? Of course, he's going to slow down a bit. But anyway, so what does this mean about the number of minutes he swims for on Tuesday? Tick the correct box. Okay, so coming back to our calculation, if he swims at a slower speed, then this value on the bottom of my calculation here would have got less. So that means I would have a smaller denominator, and when you divide through by a smaller denominator, you end up with a bigger value overall, don't you? So that will go up, which means that will go up, which means my answer is going to be more than the true answer is going to be more than what I just calculated it to be. Okay, so if he swims slower, it's going to take him longer. Kind of makes sense, doesn't it? Question 7, draw the graph of y equals 1 minus a half x for the values of x from -2 to 4. Okay, so I'm just going to do this using the table function of my calculator. First off, I'm going to just draw an xy grid, so I've got my points. So I'm going to do the numbers -2, -1, 0, 1, 2, 3, 4. I'm going to work them out, plonk them on, and the job's are good. Right, so calculator function. Going to put it in table mode. Okay, and then I'm going to press the little options key here to type in the function. My function is 1 minus, what we've got, 1 over half of x. I'm just going to type that in as 0.5x, I think. That's going to be the easiest way to type that in, isn't it? So 1 minus 0.5x. Okay, so then that's that. So then next I'm going to put in the table range. So pressing options again, I'm going to say my table starts at -2 and it stops at 4. And I want every number in between. So I want to go up in ones. So that's going to give me my table of values then. So for -2, you can see I've got the value 2. And then underneath that, I've got 1.5. And then I've got 1. And then I've got 0.5. And then I've got 0. And then I've got -0.5. And then I've got -1. Okay? Now, I I think this is going to be a straight line, isn't it? Because I've just got like y equals mx plus c. So I think I'm not going to bother plotting the half points. I'm just going to draw like the solid ones and make my life a little bit easier. Okay, so I'm going to plot the points. Minus 2, 2. Minus 2, 2. 0, 1. 2, 0. And 4 minus 1. Now obviously if it wasn't a linear equation, I'd probably want to plot those ones in between because I want to draw my best possible line, but because it's linear, it's going to be a straight line anyway. I just need to draw a line through them. I only really need 2 points, so 4 is plenty. Okay, so let's draw a straight line through those 4 x's then. So laying a ruler over them and then join them up with a straight line. Going to get something like that. Okay, so don't start and end with your first and last point. Your line should go the full width of your graph paper like mine does. Yeah, and it should be a straight line, which mine is. 4 people take part in a television talent show. Here are Amy's marks from the 6 judges. The pie chart represents the phone vote. Amy's total score is found by 4 times the mean of her marks plus her percentage of the phone vote. Work out the Amy's total score. Okay. So we've got Amy's marks from the 6 judges, so we need to find the mean of that and then times it by 4, and that's the first component then. So mean, let's do mean first. Mean is all of the numbers added up divided by the total number of numbers. So it's going to be 8 plus 9 plus 9 plus 6 plus 9 plus 10, all divided by, how many numbers are there? There are 6 numbers, so divide that by 6. Okay, so what is 8 plus 9 plus 9 plus 6 plus 9 plus 10? That comes to 51. 8 plus 9 plus 9 plus 6 plus 9 plus 10. Okay, comes to 51. And I want to divide that by 6. And that comes to, well, that comes to 8.5. So the mean is 8.5. Okay, so we also want to know what her percentage was. So her total score then is going to be 4 times the mean, which is 8.5, plus her percentage, which we haven't found yet. So Amy, you can see here, has 162 degrees of this pie chart. So she would have got, from the phone vote, she would have got 162 360. That's times 100% then, isn't it? Okay, so if we want to work it out as a percentage, so we're going to have to work it as a fraction and then times by 100, and that's going to be our percentage then, isn't it? So what's that? 162 divided by 360 times 100. That comes out to be 45%. Okay, so we're going to do 4 lots of 85 plus the 45 then, and that's going to be her total score then. So 45 plus 4 lots of 8.5, so that comes out to be 79 altogether. So that's her score, 79. Question 9. Town A has a population of 84,000 and an area of 7 square miles. Town B has a population density of 4,695 people per square kilometre. Which town has the greatest population density? Use 1 square mile is 2.6 square kilometres. Okay. So, from town A, we could work out the population density quite easily using the formula they give us. Population density is equal to population divided by area. At some point, we're going to have to convert, though, because our town A1 is in miles, square miles, and the other one is in square kilometres. So I think what I'm going to do first, I'm just going to work out what that is in kilometres by multiplying it through by 2.6. So I can use this fact down here that 1 square mile is 2.6 square kilometres. So I can say that that's equal to 7 times 2.6 then. So 7 times 2.6, that comes out to be 18.2 square kilometres. Okay, so then now I know what the area is in square kilometres, I can now work out the population in people per square kilometre by saying town A population density then is going to be the population, 84,000, divided by the area in square kilometers. So what's that? 84,000 divided by 18.2. I make that 4,615.4. I'm going to round it off to the nearest person. I don't like parts of people, so I'm just going to round it down to 4,615 people. Okay, so then comparing that to town B, you can see that it's slightly less dense, isn't it? I've got 4,615 versus 4,695. So pop B is more dense. Which way do I have to do it? Which town is the greatest population density? Gonna be town B. Gonna tick that box there. It says show working to support your answer. I've already done that, haven't I? That's what I just scribbled up there. Don't necessarily have to do it on the lines as long as it's somewhere in the gap. That is all okay. Question 10. On a biased dice, the probability of lands on 6 is 0.38. The dice is rolled 150 times. How many times would you expect the dice not to land on 6? Okay. Well, yeah, I mean, like normally, probability of landing on 6 would be a 6, which is something like, it's going to be something like 0.17, something like that. So this is more than twice as likely to land on 6 than a true dice. So, yeah, definitely biased. So the probability that lands on 6 is 0.38, but we want to work out the number of times it doesn't land on 6. So what's the probability of not 6? So the probability of not 6 is 1 minus that then, isn't it? 0.38. 1 minus 0.38, that's going to be 0.62. So the probability it lands not on a 6 is 0.62. So how many times would we expect the dice not to land on 6 in 150 rolls? Well, expected number of successes is number of trials times the relative frequency, or probability if you're doing probability. In this case, is relative frequency. So it's going to be 150 trials times my relative frequency of not getting a 6 of 0.62. So what's that then? 150 times 0.62. 150 times 0.62. That comes out to be 93. So we expect it to not be a 6 93 times. So it's going to be a 6 quite a few times, isn't it? 93. Question 11. Write a number in each box to make the calculations correct. 10 divided by 0.2 times something is 5. Well, 10 divided by 0.2, that so far is going to be minus 5. So if we want to flip that into positive 5, I guess we need to times it by minus 1 then, don't we? So times it by a negative 1 isn't going to change its value, but the negative sign is going to flip the sign from negative to positive. So by negative 1 there. Okay, 1/3 times something times 6 is 8 pi. Well, 1/3 times 6 is 2. So if I want to times something by 2 to get 8 pi, then I guess it needs to be 4 pi then, doesn't it? So the 4 pi times 2 is going to give me 8 pi altogether. Question 12. Cards are either gold or not gold. Probability of gold is 0.05. Harim chooses a card at random and replaces it. He then chooses a second card. Complete the tree diagram. So this is important that he replaces it. That means we've got independent probability and the chances of picking gold on the second try is exactly the same as it is on the first try because there's the same number of gold cards in there. Okay. Remember, with every branch, the probability is sum to 1. So if I've got 0.05 on the top there of that branch, then underneath I'm going to have 0.95 because those two numbers add up to 1. So similarly, I'm going to have 0.95 here. And because it's independent probability, it's just going to repeat down here as well. So 0.05 and 0.95. Okay, so that's all our probability tree done. And then, so the next part of the question says, what is the probability that at least one of Harim's cards is gold? So the probability of at least one gold card. Now, at least one gold card means he could get either 2 gold cards, which is that route, or he could get 1 gold card that way, or he could get 1 gold card that way. Now, I could work out those 3 routes and then add them all up, and that would give me my probability of at least 1 gold card. But the smarter thing to do is to work out this route, because there's only one of them, and take it away from 1. So I can say that that is the same thing as 1 minus the probability of no gold cards. Okay, so that will speed up my maths a little bit because I have to work out one route. So that's going to be the probability of not gold is going to be, what's that, 0.95 times 0.95? That comes out to be 361 over 400. I'm just going to leave it as a fraction. Okay, so like I say, I could have done it the other way. I could have added up, I could have worked out all 3 and added them up, but that's long, isn't it? So I'm just going to do it the quick way. So 361 over 400. So take that away from 1. So I've got 400 400s, and I take 361 400s away. That leaves me with 39 400s, doesn't it? So that's my answer, 39 400s. Decimals are fine, but fractions are your friends. Use fractions if you can. No harm in it, and it saves on you doing one extra step. Question 13. Here's a quadratic graph with the equation y equals to some function in x, and it wants me to write down the roots of the equations, f of x equal to 0. Well, f of x equal to 0 is the x-axis, so what we're basically asking is where our graph cuts through the x-axis. There are our roots, so we've got one root here and one root here. Okay, so I just really need to read those numbers off the scale. So that one on the left, x is going to be equal to, well, it's like 2 little squares along from -2, and there are 10 going up to -3. So that's going to be minus 2.2. So that's one of my roots. And the other one is smack bang between 1 and 2, isn't it? So that's x is equal to 1.5. That's my second root. So minus 2.2 and 1.5. Question 14, we have got a quadrilateral, and we're told that the angle B is 45 degrees. That's not on the diagram, I'm just going to write it in before I forget. So that's 45 degrees down there. And I'm told that A to B is in the ratio of 7 to 3, and x to y is in the ratio of 4 to 1. Show that A to y is equal to 5 to 2. Okay. So I know that A to B is in the ratio of 7 to 3, and I know B is 45. So let's start with that one then. So if I've got A to B and in the ratio of 7 to 3, but I know B is 45, then I can get 45 from 3 by multiplying through by 15, I guess. 15, 30, 45. So if I do the same thing the other side, I should get A then, shouldn't I? So 7 times 15, what's that? 7 tens are 70, and 7 fives are 35. That's 105. So 105. So that means that A must be 105. Okay. Now, we know it's quadrilateral, so we know that all of the angles add up to 360. So I know that A plus B plus x plus y equals 360. Got that kind of falling off the edge. Let me just move it in a little bit. Okay, but we know what A and B are now. We know that they're 105 and 45. So 105 plus 45 plus our unknowns x and y must be 360. So 105 and 45 together, that's 150. And if I take 150 away from both sides, then that tells me that x plus y must be 210. Okay, so now I've got 210 degrees to share between x and y. And I know that x and y are in the ratio of 4 to 1. So I can do like a divide by a ratio question now. So I've got 4 parts and 1 part, so that adds up to 5 parts. I know that 210 divided by 5 is equal to 210 divided by 5. That's 42, isn't it? Okay, so if I take my original ratio of x to y, which I know is 4 to 1, and I scale it up by a factor of 42. Okay, both sides. Then I know that x is going to be 4 lots of 42. Well, 4 40s is 160 plus 4 2s is 8. So that's 168 degrees. And then the other one is 42 degrees. So y is 42. Okay. So now I've found all the angles. X was 168 and y was 42. Okay, now what do we need? Show that a to y is 5 to 2. Well, then the ratio of a to y is going to be 105 to 42. So I want to see if that counts us down. I'm just going to use the fraction key on my calculator because that will simplify it for me, and ratios simplify the same way. So 42 1/05 on my calculator is the same as 2/5. So then that does then cancel down to 5 to 2 as requested. Okay, so yeah, that is what we wanted. Question 15. A straight line passes through points A, which has coordinates -5, 9, and B and C, which has coordinates 3, -7. They don't tell us what B is. A to B to B to C is in the ratio of 1 to 3. Work out the coordinates of point B. Okay. Well, what we need to do is work out how far away A to C is and then ratio that in the ratio of 1 to 3. And then we should be able to find out what B is. So let's have a look at their x coordinates. I've got -5 up to 3. So how many units does that span? So -5 to 3. 3 take away -5. That spans 8 units, doesn't it? So if I was going to divide that in the ratio of 1 to 3, then got 1 part plus 3 parts is 4 parts. Each part must be worth 2. So that's going to be 2 to 6 then, isn't it? So the x coordinate is going to go down by 2. So then -5 would be going down 2 is going to take me down to -3. And then to get down to C, I'm going to have to add the other 6 on, wouldn't I? And then -3 plus that 6 is going to take me up to 3. I'm going to do the same thing with the y coordinates. So the y coordinates start at 9 and go down to -7. So what's that then? So 9 take away -7. That spans 16 units. So if I want to divide that in the ratio of 1 to 3, then that is going to be 16 divided by 4 is 4. So that would be 4 to 12 then, isn't it? So I'm going to be going down 4 units in the y direction. So if I'm at 9 and I take away 4, that's going to be 5. So this point here then is the point -3, 5, which is about 1/4 of the way through the line if you think about it. 3 looks a bit rubbish. Let me just write that like a proper 3. And so then part B says, work out the equation of the line perpendicular to AC that passes through C. So we want this line going like this, which is at right angles to this point here. Okay. Now, in order to do that, we need to work out the gradient. So gradient of AC to start with. So the gradient of AC, I'm going to call it M1. So I'm going to use the formula y2 minus y1, the change in y divided by x2 minus x1, the change in x. So taking my two y coordinates, I'm going to get 9, take away -7 on the top, and then on the bottom I'm going to get -5, take away 3. So that is equal to 9 take away -7 is 16. -5 take away 3 is -8. So that comes out to be -2 altogether. So the gradient of my original line AC is -2. So therefore, gradient of the perpendicular is going to be, well, it's going to be the negative reciprocal, isn't it? So M2 is going to be -1/M1, isn't it? It's going to be, so we flip that over, get a half and change the sign. So it's going to be have a gradient of a half then. Okay, looks about right for my sketch, isn't it? So we take what we've got there, -2/1, we flip it over and get 1/2, and we flip the sign. So anyway, the gradient is a half. So therefore, equation is going to be of form y equals mx plus c, where we know that the gradient is a half. So y equals a half x plus c, and we know it passes through the point C, which has coordinates 3, minus 7. So if we sub those into our partial equation, it should be able to tell us what C is then, and we can complete the equation then. So y is going to be minus 7 plus a half of x, which is 3, plus c. So half of 3 is 1.5. Taking that away from both sides, I'm going to get c is minus 8.5 then, aren't I? So then the equation of my line then, y is equal to a half x minus 8.5 then. Question 16. Jing rolls a fair six-sided die 72 times. Is the relative frequency of rolling a 5 greater than the theoretical probability? Tick a box. Yes or no. So it's a fair six-sided dice and we're rolling it 72 times. So from the theoretical, the probability of rolling a 5 is just going to be 1 over 6, isn't it? Because there's 6 sides on your dice, it's fair. Each one's going to come up the same amount of time, just 1/6. Now, what is the relative frequency? So from experimental probability, then the relative frequency is going to be the number of successful trials. So we see here that we got 14 5s. So it's going to be 14 over 72, because we rolled it 72 times. So what's that then? So 14 divided by 72. Now that's 736. And 1/6 is 636. So you can see already that then the relative frequency is slightly more, then, isn't it? So I'm going to say, is the relative frequency rolling a 5 greater than the theoretical probability? Yes, it is, because I've got 736 and not 636. Okay? Question 17a. A and b are different prime numbers. I know that a cubed times b squared is 200. Work out the value of a to the power 4 times b. Okay, so a and b are primes. So what are the cubes and the squares of primes? Low primes, I guess, because remember I have to multiply these together, so they're not going to be terribly big. Okay, so prime numbers, let's just do the first few primes. 2, 3, 5, 7, 11. I think I'll stop there because it's already quite big. And then squares, we're going to get 4, 9, 25, 49, and 121. And cubes, well, 2 cubed is 8, 3 cubes is 27, 5 cubed is 125. 7 cubed, I think it's going to be too big, isn't it? It's already going to be bigger than 200s. I'm not going to bother with the 7s and 11s, actually. Okay, I'm just going to kind of cut there and see if I can work out what it is. So I need 2 of these things that multiply together to give me 200. Okay, so I need a square and a cube multiplied together. It gives me 200. I'm looking at the 25 and the 8, I think. 25 and the 8. That would work, wouldn't it? 8 times 25 is 200. So that would be a cubed would be the 2 cubed then, wouldn't it? It'd be 2 cubed times 5 squared equaling 200. So then a is 2 and b is 5 from my working out. So work out the value of a to the power 4 times b. So a to the power 4 times b is going to be equal to 2 to the power of 4 times 5 then, isn't it? Okay, so what's 2 to the power 4? 2, 4, 8, 16. It's going to be 16 times 5. 16 times 5 is 80. Okay, yeah, so it's going to be 80. Part B says C and D are different prime numbers. Circle the equation for which C to the power 4 times D squared times E is a cube number. Well, I guess for it to be a cube number, then these powers of C and D need to be multiples of 3, don't they? So that you can cube root it. Remember when you cube root something, let's say I had C to the power of 6 and I cube root it. I'm timesing it by the fraction of 1/3. So as long as this number here is a multiple of 3, then I can cube root it easily enough, can't I? Because a third I can divide 6 by 3 and get 2. So that means that these numbers here, after I multiply it through by E, need to be multiples of 3. So really, I need to have a couple more C's to make C to the power 6 and a D then, don't I? If I can have C squared, if I times it by C to the 4, I'm going to get C6. And if I have a D, I'm going to get D cubed, which is plenty as well. So I think it's going to be that one there. Okay, because then that's going to give me C to the 6 D cubed altogether when I multiply it through. And then I can easily then cube root it then, can't I? Which is going to be C squared times D, and that's going to be the cube root. Okay, so that's going to be a whole number, so that's all lovely. Yeah, so it's that one there. Question 18. Here is a triangle A. Use the sine rule to show that x equals 64 degrees to the nearest degree. Okay, so we want to try and find x, which is an angle. So we're going to use the version of the sine rule with the angles on the top. So like sine A over A equals sine B over B equals sine X over X. Okay, so let's label up these so it's compatible with the sine rule. If I'm gonna say that one's A and that one's B and that one's C, then this is side A and this is side B and this is side C that I don't care about. So then for the sine rule, I'm going to start with the angles on the top. Sine A over A equals sine B over B, which is equal to sine C over C, which I do not need in this part. So I'm just going to stop there. So subbing in from my diagram. So sine of A, that's the sine of X, over A, which is 11. And that's equal to the sine of B, which is the sine of 35, divided by B, which is 7. Need a bit more space. So rearranging. So sine X equals 11 sine 35 over 7. So then X is going to be the inverse sine of 11 sine 35 over 7, then, isn't it? So tapping that into the calculator, shift sine, the inverse sine, going to use the fraction key, and I write 11 sine 35. You need to close the brackets here, otherwise it'll break. And then divide that by 7. Come out, close bracket. Don't want this breaking. So there we go. And that comes out to be 64.33. Which is pretty close to 64, isn't it? Okay. Okay, part B, I've got another triangle here. Anna thinks that W must be 64 to the nearest degree. She says this is because triangle B is 2 sides and one angle the same as triangle A. Without further calculation, is she correct? Tick a box, yes or no. Well, she's assuming they're 2 congruent triangles, isn't she? So if you have a look at this one, I've got my 7 nestled between the W and the 35 there. Whereas in my other one, I've not got my 7 between the unknown angle and the 35. It's a different side, isn't it? Okay, so I'm going to say no. It is not the same. Is she correct? No. Not congruent triangles as sides and angles do not match up. Question 19. F of x equals x minus 3 and g of x equals 4x minus 7. Work out the value of fg of 6. Okay, so fg of 6 means you put 6 into g, and then whatever you get, put into f. You can think of it as like two function machines. So if I've got like a function machine for f of x and a function machine for g of x, then what I'm doing then is I'm going to feed 6 into the g of x function and then loop it round and then feed it into the f of x function. That's kind of what I'm doing with f of g of x. That's kind of what it means. Okay, so I'm going to take 6 and I'm going to put it in g first. So g of 6, that's equal to 4 lots of 6 minus 7. So 4 6s are 24, take away 7, that's 17. And then what I'm going to do, so if 17 came out of here, then I would loop it back and then feed it into f of x. So I'm going to find f of 17 now and see what I get. So what is f of 17? F of 17 is going to be 17 minus 3, which is 14. So the answer is 14. Right, and then part B says solve f of x all squared equals g of x. Well, what is f of x all squared to start with? If I've got f of x equals x minus 3, then f of x squared then is going to be equal to, well, it's going to be x minus 3 all squared. So if I'm squaring that one, do you know your perfect square identity? A plus b all squared is identical to a squared plus 2ab plus b squared. It's kind of helpful when you're multiplying out these brackets, because it means I can just do this. That's going to give me x squared minus 6x plus 9. Okay, it's just the first term squared, 2 times the two terms multiplied together, and then the last term squared. So I'm just use that as a quick way of multiplying these out without having to do the brackets. But if you don't get that, just do the brackets. X minus 3, and FOIL it. Okay, so that's f of x all squared. Now I want to know the values of x, which that is equal to g of x. So when is x squared minus 6x plus 9 equal to g of x? For x minus 7. Okay, now I can bring everything to one side, I guess, and form a quadratic. So taking 4x away from both sides, that's going to give me x squared minus 10x plus 9 is equal to minus 7, and then add in 7 to both sides. That's going to give me x squared minus 10x plus 16 is equal to 0. So now what I want to do is try and factorize this, or if not, solve by the formula. Hopefully factorize. So it starts with x squared. So I'm guessing it's got an x and x at the beginning. That gives me my x squared. It ends in 16. So what are the factor pairs of 16? So 16 factor pairs could have 1 and 16. It's a possibility. 2 and 8. 4 and 0. Or 4 and 4. Okay, so they're my 3 possible pairs. Now I'm looking for a pair that sums to minus 10. So I'm guessing it's going to be those, because if I've got a plus at the end and a minus in the middle, I must have minus minus, and the minus 2 and the minus 8 is going to make minus 10. Okay, so good. So I've got x minus 2, x minus 8 is equal to 0. So if I've got two things multiplied together equals 0, that means that one of them must be 0, or the other one must be 0. In other words, x is equal to 2 or x is equal to 8. Okay, so they're my solutions. They're my values of x that satisfy f of x all squared equals g of x. Question 20. P, Q and R have positive values. P is directly proportional to Q when P is 8, Q is 2. R is inversely proportional to Q squared when R is 10, Q is 3. Work out the value of R when P is 0.5. Okay, so got two proportionality things here rolled into one. I know that P is proportional to Q, so P must be equal to some multiple of Q. And I know that when P is equal to 8, Q is equal to 2. So subbing those in, it tells me then that 8 is equal to K lots of 2. So then K must be 4. And therefore, P is equal to 4Q. It's our formula linking P and Q. Okay, so halfway there. So now we know what P and Q relate. We know that R is inversely proportional. That means 1 over the square of Q. So R is proportional to 1 over Q squared. So that means that R is equal to some constant over Q squared. And we know then when R is 10, Q is 3. So subbing those two values in, 10 then must be equal to K over 3 squared, which is 9. Cross multiplying that, that tells me then that K must be 90. So then that means that R must be 90 over Q squared then. Okay? Right, so we're good. We've got an equation for P in terms of Q, and we've got an equation for R in terms of Q. What we want is an equation in R in terms of P. So we kind of need to sub one inside the other, okay? So what's going to happen here then? So I can say that from this one up here, if P equals 4Q, then Q is going to be P over 4 then, isn't it? So I can call that equation 1, and this is going to be in my equation 2, and I'm going to sub equation 1 into equation 2 to find a different equation in R and P, hopefully. So substituting equation 1 into equation 2, I'm going to get R is equal to 90 over Q squared, but this is where I'm going to replace Q with P over 4 then. So where Q is, I'm going to write P over 4. So that's going to be P over 4 squared. So we're dividing through by a fraction here, isn't it? So I think what I'm going to do is going to flip it over in times after I square it. That's going to be P squared over 16 when I kind of multiply out that bracket. So it's 90 divided by P squared over 16. So when you divide through by a fraction, you can keep flip, can't you? So rather than dividing through by P squared over 16, I can times through by 16 over P squared then, can't I? Okay, so doing great, doing great. So 90 times 16 over P squared, so that means R is going to be, what's 90 times 16? That's 1,440 over P squared. So what is the value of that when P is 0.5? So when P is 0.5, we're going to get, keep running out of space, we're going to get R is equal to 1440 over 0.5 squared then, aren't we? So what is 1,440 divided by 0.5 squared? Apparently that's 5,760. Okay, so that's going to be my answer, 5760. Question 21. A cylinder C and a sphere S each have a radius of R. C has a height of H. The volume of C is equal to the volume of S. Work out the ratio of R to H. You must show your working. And they've handily given us the volume of a sphere formula, which is jolly nice of them, isn't it? Right, but they haven't given us the formula for the cylinder, but luckily we know a cylinder is just a circular prism, and we know for any prism its volume is the area of the cross section, which in this case is a circle, so it's pi r squared, times the height of the shape. So then the volume of the cylinder is going to be pi r squared h then, isn't it? Okay, so the volume of the cylinder is pi r squared h, and we know the volume of the sphere is equal to 4/3 pi r cubed, and we know that these two things are equal. We know that the volume of the sphere is equal to the volume of the cylinder. So that means pi r squared h must be equal to 4/3 of pi r cubed. Right, now we've got lots of things occurring on both sides which we can then cancel out. So if I divide both sides by pi, they would both disappear. And if I divide both sides by r squared, then r squared will disappear here. And because I've got r cubed on the other side, if I divide it by r squared, it's just going to leave me with r. Okay, so I'm going to end up with h equals 4r over 3. Is that what I want? Work out the ratio of r to h. Okay, so what is the ratio of r to h? Well, let's say we made r equal 1 and I subbed in that formula, then h would be 4 times 1 over 3, which would be 4/3, wouldn't it? So r to h is going to be in the ratio of 1 to 4/3. It's not so nice having a fraction in there. So if I multiply both sides through by 3, just to tidy it up a little bit, I'm going to get the ratio of 3 to 4 then. Okay? So it looked fairly horrendous, but actually it's just maths. 21b, a different cylinder has radius of 3r and height of 2h. How many times bigger is the volume of this cylinder than the volume of C? Okay, so remember the volume of C was pi r squared h. Now this one is got a radius of 3r and a height of 2h. So then its volume is going to be the area of the cross section, which is pi r squared, but r here is actually 3r, so it's going to be pi 3r squared, and then we're going to times it by the height, but in this case the height is not h, it's 2h, so it's going to be 2h like that. Okay, so what's that then? Squaring that 3r all squared is going to be, remember you have to square both things. I can't just square the r, I'm going to have to square the 3 as well. So that's going to give me pi times 9r times 2h. And then collecting all the numbers at the front then, 9 times 2 is 18. So that's going to give me, oh, forgot my square there. That's going to give me 18 pi r squared h. Okay, so I had pi r squared h, I've got 18 pi r squared h, so this is 18 lots of the area of VC then, isn't it? So how many times bigger is my new chunky cylinder? It's 18 times bigger. Question 22. Fatima is choosing a 4-digit code. Each digit is a whole number from 0 to 9. She decides all her digits will be odd numbers. No digit will be repeated. How many different codes can she make? Okay, so we can't have the whole numbers between 0 and 9. It has to be odd. What are the odd numbers? Between 0 and 9, I could have 1, I could have 3, I could have 5, I could have 7, I could have 9. There are 5 of them, aren't there? Okay, now if I want to make a 4-digit code, then I need to fill these 4 boxes with one of those numbers. Okay, and because it doesn't repeat, every time I pick one to fill in one of the boxes, I'm going to have one less for my next choice. So for the first box, I've got 5 choices. I can have 1, 3, 5, 7, or 9. So I've got 5 choices for that one. But for the second one, let's say I chose 1, then I've only got 4 left to put in the next box to pick from. So I'm going to have 4 choices for my second box. Now let's say I chose 3, then I'd only have 3 left for my third choice. So that's 3, and then similarly I'd only have 2 left for my last choice. Okay, so how many different codes is that? Well, we just simply multiply these together now. 5 times 4 times 3 times 2. What's that equal to then? 5 times 4 times 3 times 2, that comes to 120. So there are 120 different codes. Question 23. Quadrilateral ABCD is reflected in edge BC. how many of the vertices are invariant? Circle your answer. Okay, well, let's have a think about this. A, B, C, D. So A, B, C, D. So BC is the mirror line. BC. So it's going to be reflected in that mirror line. So image is going to look something like this, isn't it? So that's going to be A dash, D dash over there. Now B and C lie on the mirror line. So B dash and C dash are also going to be on the mirror line. So those 2 points are invariant. So how many of the vertices are invariant? 2 of them. Okay. Question 24, write 2x squared minus 12x plus 7 in the form d lots of x plus e all squared plus f, where d, e and f are integers. So this is the harder version of the completed square form, where you've got a coefficient of x squared that is not equal to 1. So in this case, what you need to do is factorize out that coefficient of x squared out the first 2 terms before you do anything else. So what I'm going to do is going to factorize out 2 out of the first 2 terms. So that's going to give me 2 lots of x squared minus 6x, okay? And then I've got that plus 7 on the end, okay? Had plus 7, still got plus 7. All I've done is I've taken 2 out of the first 2 terms. Agreed? Right, then when we're completing the square, we have to half the coefficient of x, don't we? But when you've got a number in front of x squared, it's half of this one. It's the one here after you've factorized the 2 out. Okay, so it's going to be half of that 6 there, which is going to be in my bracket. So it's going to be 2 lots of, I'm going to get x minus 3 all squared. Half of 6 is 3. Now remember, you then need to take away the square of that 3. So we take away a 9, and we've still got the 7 on the end, like that. Okay, now notice how I placed those square brackets. I did it on purpose because I need to take this minus 9 and join it up with the 7, but when I pop it out of this bracket, it's going to have to be multiplied by that 2 that's sitting in the front here, look, because it's 2 lots of everything inside that bracket. So if I take it out of the bracket, I'm going to have to double it as it pops out. Okay, so when I take it out of the bracket, I'm going to get 2 lots of x minus 3 all squared minus 18 plus 7. Okay, and then finally I'm going to then join those numbers up at the end. The minus 18 plus the 7 is going to give you minus 11 on the end. Now, it's a bit cheeky putting these sort of ones in. They're quite tricky. Normally they only come up on the further maths, so if you're a further mathematician, you probably had experience of doing these ones, and if not, you probably haven't had a lot of experience of doing it, because most maths teachers don't bother teaching it. It rarely comes up. But in this case it did, and it was worth 3 marks, so wow. Okay, better make sure you know how to do it then.
You can find more exam question compilations over here. For more past paper walkthroughs, click down here. If you want to visit my Amazon shop with my recommendations for calculators, revision guides and other maths related stuff, click down here. Good luck in your revision and in your exams.